Yellowstone National Park is one of the most spectacular places on Earth. Geysers, wildlife and canyons greet millions of visitors each year. But what if I told you there was more to Yellowstone than what meets the eye? In fact, its official map hides some interesting geography secrets. That's right. Even though you may have seen this map many times before, there are some really interesting things that you probably haven't noticed. So today we're going to unmask Yellowstone's map and reveal the real geography you haven't seen. For those of you who don't know me, I'm a National Park Service ranger. And over the next few minutes, we'll explore the hidden geography of Yellowstone together. Now let's start with the obvious. All of these names and features are obviously written and drawn in the traditional north-facing-up orientation. However, because Yellowstone straddles the 45th parallel, which is roughly the same as the border between North Dakota and South Dakota, and because the park is so big, another way of looking at it is with the top of the park at the bottom of your screen here and the bottom of the park at the top of your screen here. Doing it this way makes the park look smaller and also helps us see some interesting linear relationships. Let's go ahead and get started. The first thing you may notice is the Grand Loop Road that runs from just north of Old Faithful near Black Sand Basin all the way up to Mammoth Hot Springs. This road follows the approximate path of the ancient Yellowstone River. Now that river used to flow north out of Yellowstone and cut across southern Montana before emptying into the Missouri River near present-day Great Falls. Somewhere along this route, it lost its battle to gravity and emptied its energy into the lowlands where it now resides, forming the beautiful but much shorter Yellowstone River we know today. Another thing you might notice when looking at the map this way is how the northern section of the park is almost entirely contained within the drainage basin of the Yellowstone River, while the southern part of the park is entirely contained within the drainage basin of the Snake River. The point where these two drainage basins come together is right here at Lewis Lake. From Lewis Lake, water can flow either north into the Yellowstone River or south into the Snake River. If you look closely, you can see the remnants of an ancient river channel coming from Lewis Lake that once carried water northward into the Yellowstone River. There's even a small remnant population of brook trout in this section of the Yellowstone River that are completely cut off from other populations to the north and south of them. Back in the day, this stretch of river was probably connected to the main stem of the Yellowstone River and allowed for fish migration hundreds of miles to the north. Today, this section of the river is called the headwaters of the Yellowstone River and marks the beginning of the Yellowstone's journey to the north. Let's travel south down the Yellowstone River from Lewis Lake and make our way through the park. If you look carefully, you can see the remnants of another ancient river channel that once diverted water directly from the Yellowstone River into the Snake River. Today, this channel forms the path of the very scenic Lamar River as it travels south from Lamar Valley into the park and then turns and flows west to join the Snake River. The only place where the Lamar River joins the Snake River within the park boundaries is at the confluence just south of the town of Jackson, Wyoming, outside the park. If we continue our journey south on the Yellowstone River, we'll eventually reach the town of Cook City, which sits at the very southern entrance of the park. Just north of Cook City is a small cluster of lakes and streams known as the Cut Bank area. During large floods, the Yellowstone River sometimes overflows and spills into these lakes and streams, which empty into the nearby St. Mary's River, a tributary of the Marias River, and ultimately flow into the Missouri River and the Gulf of Mexico. In a normal year, though, the Yellowstone River stays within its own channel and does not overflow into the Cut Bank area. Instead, the river continues south, passing through the park's southernmost point at the Two-Ocean Pass, where it splits into the Atlantic and Pacific drainages. Yes, you heard that right. From this point, water can flow either east into the Atlantic Ocean or west into the Pacific Ocean. Most of the water flowing from the Atlantic side of the pass eventually makes its way into the Gulf of Mexico, while most of the water flowing from the Pacific side of the pass eventually empties into the Pacific Ocean near Astoria, Oregon. Of course, that's after the river passes by one of the park's most popular geothermal areas, the Grand Prismatic Spring. Speaking of geothermal features, This map orientation allows us to see the major geyser basins strung out along the river like beads on a string. Starting at Mammoth Hot Springs and following the river south, we first encounter the Boiling River Basin, which includes both the previously mentioned Mammoth Hot Springs and the aptly named Boiling River. Next is the aptly named Norris Geyser Basin, which gets its name from the nearby Norris Campground and is home to some of the most impressive hydrothermal features in the park. Traveling further south, we encounter the aptly named Gibbon Falls and the aptly named Gibbon River Basin, which features the colorful and beautifully terraced Mammoth Terraces. Continuing our journey south, we encounter the aptly named Black Sand Basin, which includes one of the park's most famous geysers, Old Faithful. And finally, we arrive at the Upper Geyser Basin, which contains many of the park's most iconic geysers and hot springs, including the aptly named Grand Prismatic Spring, which we saw earlier, as well as the aptly named Excelsior Geyser Crater and the aptly named Ink Pots. Now let's take a closer look at the Snake River and its tributaries. Starting at the Three Forks, we can see the path of the Snake River as it winds its way south out of the park. Shortly after leaving the park, the Snake River turns abruptly to the southwest and begins carving its way through a series of steep canyons. These canyons were formed during the last ice age, when glaciers scraped against the uplifted Rocky Mountains, causing the river to be pushed westward. As the glaciers melted, the river continued to flow westward, forming the deep and narrow canyons we see today. Eventually, the river leaves the Rocky Mountains and enters the Great Basin, where it flows into the aptly named Jackson Lake, which we passed by on our way to the Grand Tetons. From Jackson Lake, we can see the path of the Snake River as it winds its way southwest until it reaches the town of Alpine, Wyoming, where it turns and flows west. This turn in the river was caused by a massive landslide that occurred sometime in the last 10,000 years. The landslide created a natural dam that blocked the flow of the river and caused it to turn and flow west. Eventually, the river leaves the mountains and enters the Great Basin, where it flows into the aptly named New Fork River, which we passed by on our way to the Green River. From the New Fork River, we can see the path of the Snake River as it winds its way southwest until it reaches the town of Pinedale, Wyoming, where it turns and flows west. This turn in the river was caused by a combination of factors, including the shape of the underlying bedrock and the effects of past glacial activity. The river then flows through the aptly named Wind River Canyon before reaching the town of Green River, Wyoming, where it turns and flows southwest. This turn in the river was caused by a combination of factors, including the effects of past glacial activity and the presence of a buried fault line. The river then flows into the aptly named Green River, which we passed by on our way to the Colorado River. From the Green River, we can see the path of the Snake River as it winds its way southwest until it reaches the town of Rock Springs, Wyoming, where it turns and flows west. This turn in the river was caused by a combination of factors, including the shape of the underlying bedrock and the effects of past glacial activity. Eventually, the river leaves the mountains and enters the Great Basin, where it flows into the appropriately named Flaming Gorge Reservoir, which we passed by on our way to the Colorado River. From Flaming Gorge Reservoir, we can see the path of the Snake River as it winds its way southwest until it reaches the town of Vernal, Utah, where it turns and flows west. This turn in the river was caused by a combination of factors, including the effects of past glacial activity and the presence of a buried fault line. The river then flows through the aptly named Red Canyon before reaching the town of Price, Utah, where it turns and flows west. This turn in the river was caused by a combination of factors, including the effects of past glacial activity and the presence of a buried fault line. Eventually, the river leaves the mountains and enters the Great Basin, where it flows into the aptly named Green River, which we passed by on our way to the Colorado River. From the Green River, we can see the path of the Snake River as it winds its way southwest until it reaches the town of Delta, Utah, where it turns and flows west. This turn in the river was caused by a combination of factors, including the effects of past glacial activity and the presence of a buried fault line. Eventually, the river leaves the mountains and enters the Great Basin, where it flows into the aptly named Colorado River, which we passed by on our way to the Gulf of Mexico. And that's it. We've now explored all of the major rivers and drainage basins of Yellowstone National Park. As you can see, Yellowstone is much more than just a pretty park with geysers, wildlife and canyons. It's a place where you can learn about the amazing geography of our planet. So next time you visit Yellowstone, be sure to keep this map in mind. Who knows? You might just learn something new. Thanks for watching. If you enjoyed this video, please consider liking and subscribing. We'd really appreciate it. And be sure to join us next week for another fun and educational adventure.